connect. Oh, okay. Okay. So I can just start. Okay. So hi everybody. It's a pleasure. So I'm going to talk a little bit about what I've been doing for verification of passport signatures and the validity of passports using SNARKs. So um, so this is proof of passport. Now the repo is called Embassy because I like the name like Embassy. I wonder what you prefer between proof of passport and Embassy. So why is it interesting or important to verify that passports are valid? Well, there are two basic use cases. The first one is Sybil resistance. So it can be used by protocols that need to verify that people that use them are humans. The concept of like Sybil attacks is pretty general in computer science. It's a problem in many different fields, and especially in crypto, where people can like cheat by creating a lot of different accounts. And the other interesting thing is a selective disclosure of private data. So in your passport, basically there is an electronic chip. In this chip, there is like your personal information, and it's signed by the government that's issuing the passports. And so verifying this signature and using selective disclosure, you can selectively disclose things about yourself, for instance, your name, your nationality, or your age, without disclosing any other information. So the great thing that makes all of this possible is the ICAO, which is basically an international organization that's also linked to the UN, and that makes the specification for the passports that every airport has to comply with, and every country has to comply with. And it's basically necessary because all of the machines at the airport that verify that the passports are valid, obviously they have to comply to the same specifications, because if they did not, we couldn't know precisely what if the passports are valid or not. So what can you prove? So inside the chip of the passports, you've got multiple DG files, so DG1 up to DG16, and here is all of the data that's inside. So most of what's interesting to us is DG1, which has the MRZ, and MRZ, it's what you have here. It's like it's most of the most important information, for instance, the name and the date of birth, and a few other things. We can actually also get the photo of the face, which is DG2. So I've not used it right now, but it's possible to prove it. So maybe it could be interesting in like ZKML use cases. For instance, you prove that you have a photo with your face, and then you can do, I don't know, ML on it, like something similar to WorldCoin or something. It would be maybe an interesting use case for hackathons. And we have a bunch of upcoming hackathons this month, right, with a ZK hack and everything. So maybe like it can give you ideas. You also have fingerprints and irises. Those are not put by a lot of countries, only a few countries right now, but you can't access them using this simple basic access control mechanisms that I'm using. You have to have like private keys of governments and everything. So basically, we can't do anything with like the fingerprints and the eye scans for obvious privacy reasons. And then you've got a few other fields that most of them are not used a lot and are not that interesting. But for instance, you've got like optional things like persons to notify. So yeah, but the most interesting things are those, and especially I think the country, obviously, nationality, the date of birth, because you can, for instance, prove that you are above 18, your sex, and that's mostly it. Maybe your name could actually also be interesting. So so this is the basic structure of the circuits. Basically, what's happening is that so this is all of the data groups I've been showing you, DG1, DG2, up to DG16. And this is all of the data that's going into the MRZ. As I said earlier, MRZ is this big string with like data about yourself. And so it's all concatenated. It makes the MRZ. Then it's hashed into data hash 1. This is all of the other data hashes. And as you can see, everything that's like in this pink is inputs of the circuits. So those are then concatenated together and hashed again. And then with the date of the signature, you get something that's called the e-content in the passport. And this is what's actually hashed then signed using RSA, okay? And so basically, with all of those inputs, we can end up getting the signature with obviously the pub key from the government that verifies that the signature is correct. And in the end, we have an output which is okay, is it valid or not? Actually, the circuit right now, it's implemented in a Circom with Grow 16. So there are like 400,000 constraints, and it's mostly dominated by RSA, which is like about 150,000 constraints, and the rest is mostly dominated by the three SHA-256 here, and here. Okay, let's continue. So yeah, so for the mobile app, so obviously it's really important to have a mobile app because few people have NFC readers at home, right? But we all have an NFC reader in our pocket, which is our phone. Most phones today they actually support reading NFC, so it's pretty good. And so at the start, I started working with Halo 2 because I had the sense that Halo 2 was the best for client-side proving, and it was the fastest. But actually, it's the fastest in browsers because it's been optimized a lot to work in WASM in browsers. But and so most people today, when they are trying to do a state-of-the-art project in which they use snarks and they prove client-side, they use Halo 2. But actually, it's not the best thing for a mobile app because on a mobile app, you don't have the constraints of WASM. You can actually like compile raw code to run on bare metal, like on C++ or something like that. And so you can go way much faster with Grow 16 libraries. So basically, the app is in React Native, so it can work on either iOS or Android. It works everywhere. Then you've got passport reader modules that have been already implemented by other teams in Android, so in Kotlin or Java or Swift. And then it's calling a proving library, which is Arcworks Circom with Grow 16. And it's pretty cool because I've not tested right now on iOS, but on Android, it takes about 8 seconds for all of the proof to be done on my phone, which is not last generation. It's like Samsung S10, so it's a few years back. So I think it can be even faster on like more recent hardware. So here you can see basically how the app looks like right now. I have to input a few things which can be found on the main page. And this is necessary to be able to read the passport because if I didn't have to input those few things that I found on the main page, I could just take the passport of anybody or like just scan them in their pockets. That wouldn't be secure. And so I'm just going to click on like scan passport with NFC. Then I'm going to put it on. So it just vibrated, which means that it's reading. And then it says, okay, hi Florent, because it read my name. I could display the photo, but I've not done it right now. And then I put a field on which you can put your address to mint an SBT, but right now the SBT is not there. And I'm going to click on generate ZK proof. And so this is not going to take 8 seconds. This is going to take like a minute and a half because it's loading all of the things from the library. But actually, I think all of this loading, I can like manage to do it when you open the app. And so this button will just take like something like 8 seconds if everything works well, which is good. So let's continue while waiting. So obviously the main limitation of all of that is adoption. So this is like a pretty recent list of the countries that are issuing e-passport. Actually, it's not even up to date because there are some countries like India that are already issuing some and that are not on the map. But in most of those countries, even if they are issuing e-passports, a lot of people still have old passports that don't have an electronic chip. And so a lot of people can't use this right now. And of course, you also have a lot of people who don't have any passports. Like for instance, in the US, approximately half of the US population holds a passport because a lot of people just don't move out of the US, so they never need one. And so, no, this has not generated. Um, yeah. Um, and so basically, why are folding schemes interesting? Well, as we saw yesterday, folding schemes can like fold multiple instances of basic circuits that are doing some things. And the most important things in the circuit that take the most compute are RSA and SHA-256. RSA basically, it's modular exponentiation by this number most of the time. It's like the number that's used in every implementation used by passports. And to do this, you have to do 17 modular multiplications because thanks to the square and multiply algorithm, you can just like square multiple times the number. So you have 16 times and then one. So that you get this number. And so if we could like fold this, we could just like fold the thing maybe 17 times and that would be good. And same thing for SHA-256. Actually, it's already been implemented with Nova, and that would be cool if it was possible also. Right now, it's not possible to have a Nova proof and prove it, and also have it only be one small part in a bigger gross 16 circuit. But there is a team from PSC, and I think people from OXPark also that are working on this. And also one good thing would be to support other passport specs, because I kind of lied to you. I said that it was just RSA, but it's not true. The specification is more complex. Like most countries have done passports using RSA, and this is the circuit I implemented. But actually, you've got some passports that are also like using this thing, which is just a variant that's going to be fast to do. But you've got other ones, like for instance, RSA with the SHA-1, and you've even got UCDSA for some of them, and even like Mexico seems to have made a few passports with, I don't know, SHA-5, 512, and yeah, like Germany seems to have really loved like making some with all of the different standards. So there are already implementations of ECDSA with Circom, so I don't think it's that hard, but actually the circuits are not that complex. So if you want to like learn Circom, or you already know Circom and you want a little challenge, maybe you can try to adapt the circuits I did to one of those standards. It would be really cool, and also it would like make proof of passport better, because now it supports more countries. So this is something, and of course you can like scan it to see the repo. So now it's done the proof, so it's just logging it right now here, so you can see it. But basically it's saying, okay, the duration it's like 8 seconds, and it's showing the serial as proof. And this can basically be put into just a circum verifier on chain, and you can mint an SBT with it. So yeah, this is basically it. I hope you liked my presentation. So feel free if you have any questions. I also think that like for the upcoming hackathons, there are a lot of simple ideas around this kind of topics, with like maybe ID cards from other countries, or just like universities signing certificates. There are a lot of different things like this. Actually, the idea of this, it just came out of a hackathon a few months ago that I did with a friend. And I was just thinking, okay, like where are interesting signatures that we could verify? And it would be fun. And so I'm sure there are a lot of other ideas similar to this, and that could be implemented quite fast.
Just you enter some information before you scan the passport. What kind of...
So the information you have to put before scanning is I can show you. So it's basically the expiry date, the birth date, and the passport number, which is here. So it's basically this, and this, and it's the general specification. Like you only have to have this, and then the passport lets you read the data. So it's to make sure that you can't just like steal information from people.
You can do that anyways, right? I can just walk around in the airport.
No, you can't. You can't, because basically you have to have this few like the three things, like the passport number and the expiry date and the birth date. If you don't have them, the passport will just not talk to you. And so you can't like get the data. It's not like you get the data and then you
To read those data input and then you proceed.
exactly, because I didn't mention it there, but there is like a complex and long system, just like Bluetooth, with like oh, you're sending something and it's responding and everything, and it's what's implemented in those libraries, right? The passport reader modules. But I did not do it myself. Like those are things that have already been done in Java and Kotlin, and are quite complex, just like Bluetooth protocol and everything.
Can you prevent the use of these proofs in a person? Are there some kind of nullifying mechanisms? Is it possible for somebody else to like just pick your proof and they can personally change?
So if you generate the proof and you send it to someone, the person obviously is going to be able to impersonate you. For instance, with the SBT, you can have a basic nullifier mechanism in which like you commit to your own address within the circuit so that nobody can steal the proof. Then you put it on chain, and then on chain it like records a nullifier. It can be just a hash of the signature, and it's quite cool. The problem with that, and actually I think it's a trade-off that has no good solution, it's just a trade-off, is that if you have a public nullifier, the country that emits the signature, they can actually like you're actually making this public, and so the country can actually know maybe not everything about you, but they can know that they are the ones that emitted it. Actually, they can even know everything about you if they have like a database of everything that they signed. So this is kind of a trade-off between full anonymity, but no nullifier, and so no way to guarantee that something is not used multiple times. And on the other side, a nullifier, but less anonymity towards the emitting country.
How do you choose like the hash function?
Yeah, so there are specifications, and basically it's like mostly RSA with the SHA-256, but as I showed earlier, you also have some countries emitting some passports with the other systems.
So does that mean you need like custom servers for different?
Yeah, exactly. If I want to support everything, and so if you want to help, like everything is open source, building in public, there is no like private repos or anything, so you can just go to the repo I showed and try to implement one of them. So the only one I implemented is the one on the top, which is the most used. But yeah, like this is just a different formatting. This is not going to be really hard, but ECDSA with like other SHA formats, okay, maybe a bit of work. So it would be interesting, because obviously if it only supports some passports, it's not that general.
This file is not there in the repo, right?
This file is not in the repo. It's if you go on the organization, actually, is it pushed? No, you know what? I'm going to just push it. If you go to the organization, there is another repo, modulus extractor, and then I'm going to push it, and you will see it in a few minutes. This is like a file that I got from extracting like the formats from the official lists of public keys.
I think in the ZigML project, why they choose the Hello 2 version, because Hello 2 version will be much efficiency, much more efficient for building the lookup or the state transition, regex, something like that, substring pairing, substring match pairing. Pattern matching, something. So my question is, you mentioned that the biggest part of your circuit is the RSA verification, and then the SHA-256, right? So So, is there any circuit the gates for the substring hashing?
So there are none right now because basically ZK email they have to like look in a really big email for a specific substring. And in my case, I just have a small string which is the MRZ that basically contains all of the information I want. And so maybe if I want to do more complex things like prove some part of the image or something, I would need like some just like they did with looking at substrings inside the circuits and regexes. I don't need it right now. I just have like a few inputs that basically decide whether which parts of the MRZ are public or private. And so as there are only like 9 parts or 10, it's not that hard.
So sticking with circuit 16 is enough, right?
Yeah, it's enough. But of course, it could be even better with maybe Nova or maybe Jolt or something one day.
So right now you're proving that you know some like passport information which was signed by some government authority, right? You're not proving anything. It's not specific, like you're proving that this person is from like has this age or from this country or something, right? That is something that can be added on top of it.
Actually, you can with the current circuits because you can like input all of the information in the circuits and then say and then you say, okay, everything is going to be private except nationality. Nationality is public. And so in the end, you have this proof and you can see, okay, in the MRZ input, you've got this, which means nationality, and it's, let's say, French, for instance. And so it's like this pretty much works right now in the circuit. I just have to do the contract, like to mint things and everything, but it's not going to be that hard, I think.
So in the picture, the data hash is 1 for the hash of MRZ, right? So what
Yes.
about the data hash 2 up to the data hash 16?
So data hash 2 is the photo of the face, and we can get it. So that's cool. We can do things with the face. And then the other ones, like 3 and 4, we can't access them without big access control things that we can't have, unless we hack into the government things, but dangerous. Yes, there are many hashes, and they all have to be in the inputs because they don't actually in practice they are not in the input. This is in the inputs, and I'm just checking that this is at the right place in this. So it's a bit misleading. This is actually not input. This is in the inputs. But in the end, it's the same, right? Because you can't have collisions. So I'm just checking that the substring is at the right place in the concatenation of them. I hope it's clear.
Yeah, you go back to the one with all the data.
Yeah.
Yeah, this one. So are you saying that I cannot, the MRZ algorithm, I cannot take it, right?
This, yes, you cannot.
Why?
So basically, this okay, this corresponds to the string you have on your passport, which is this. Okay, so this is P. This means it's a passport. Then there is just a character that separates. FRA means France. Then there is my last name and everything. This is all going to be concatenated into this big string that I just showed you. And then it's going to be hashed. And then it's an input in all of this. So it's hashed again, concatenated and everything into the signature. And so basically, if you try to mess up with something like this, you try to change it. Okay, this is going to give you another hash. This is SHA-256. We don't know how to break it. Then again, then you won't ever have the signature of your government.
It's signed by the government.
This is signed by the government. This at the end.
In the NFC.
Yes, in the NFC chip, there is all of the data plus the signature.
The signatures, the French government, the signatures for the Indian government.
Exactly. Every country has different pub keys and everything. Actually, what the numbers that you can see here, for instance, okay, for Canada, here you have like 703, it's because the countries, they are often creating new keys for security purposes. They don't want to just have one key and sign everything with it. And so they have a process every few months, they generate new keys and they change. And so this is the number of pub keys that have been used, or private keys. For instance, Canada has used this number of pub keys to sign this format, but I think they also use other formattings because they don't know to decide. They like making much, even if they don't, they could just use one. But same thing for like New Zealand.
So basically, you have to build many circuit for each country.
If we want to cover all of the world, yes, unfortunately, yeah, maybe the ICAO could have just said, okay, just use RSA 256. It's simple, it works, but you know,
But I think processing has this problem that they have to the first circuit customs first set up. It could be a issue. So if you can write the second circuit and then compile to the bank, compile to feed into bank system will be better. So yeah, so I just wondering if our boss has a a bank. So for you it would be easier to shift to that.
Third party support for long. It's not natively substituted by library, but third party support.
Okay.
so yeah, if there is a Plonk backend for ArcWorks, and yeah, it might be a good idea. Yeah, it
You
might
just
be
use
good.
the ISRs from the Ethereum.
Okay.
From there.
Well, that might be a good idea. I'll look.
Otherwise, you have to do a ceremony.
Yeah.
Yeah.
Um,
Are there any standardization efforts to like use similar signature algorithms why are all these countries fragmenting towards different?
I don't know if there are any particular efforts. I know that the things at the airports that check, they can check all of them because they have to implement the full specification. I don't know. It seems like the countries naturally have just gone towards this one, but you know, there are always few black sheeps wanting to do like this one. So this comes from the master lists. The master lists basically are those big lists with all of the public keys. And there are multiple of them because it's often like countries like France or Germany that, or even the ICAO is also doing it. They're just compiling all of the private keys, all of the public keys of all of the governments. They are sent between each other, and then they make often big lists, and they sign it to attest that it's true. But you don't have you don't have basically one central authority for it. Like France will publish the master list from all of the countries it has communicated with. It's a bit like DNS, like for HTTPS. Yeah.
So if I'm a passport authority in Myanmar, I have a French passport, somebody comes, I need to keep updating my list for French passports and for other.
Yeah, but in practice, you would just download the master list that is published by the ACO or by Germany. And in the master list, you should have everything needed.
And it's all RSA signatures, most of it.
As you can see, like this, most of it are RSA. This is RSA also. This is RSA also, but you've got some ECDSA. So we will need to work on this.
We didn't get signature date because there's a signature date.
There's a signature date. It's somewhere in the passport. Actually, I don't even need it when I verify because in practice, I just take the digest. It's concatenated with signature to make e-content with, I don't put it here, but there's a lot of padding of like formatting. But I just check that the digest is at the right place in the e-content. So basically, you can put everything you want in the signature date in the circuit, but if you put something that's not true, you're never going to end up with the right SHA-256 because you can't do collisions. You'd have to break the whole hash.
The original information is also in the signature.
Yeah.
Okay.
Yeah, in the end, everything that you see here ends up in the signature, so you can't cheat on anything here, even on all of the other data hashes that I'm not using.
Therefore, it doesn't show that part. It is only sign the hash.
Yeah, they only sign at the end the hash.
Okay, what's next then?
What's
What's
well,
the-
next is supporting like all of the signature schemes. Then we have a pretty good like public good that people can use if they want in their projects. Personally, I don't think the future of like ZK identity is just one thing that's going to verify all human like black or white. I think it's too easy to cheat if you do systems like that. Like if I want to create multiple accounts, I just have to take the passports of my mother, my father. They don't know anything about crypto. Okay, I'll create multiple accounts. They won't even notice. I think in the future it's going to be more like aggregation of multiple things. For instance, I have a profile. I verified my passport. I verified my, I don't know, phone number. I verified I have an address on the Ethereum mainnet in which I did this and this transfers. Maybe I also did the Walkcoin thing. And so now, okay, it could be false. Maybe I just did all of that, but it's quite harder to cheat. Maybe I can just like to me it's like ZK singularity or ZK identity singularity. Like in the future, if more and more things can be proven on chain, then we can aggregate more and more different things and make it harder and harder to to cheat. For instance, if I can also support the French ID card, then I can prove that I have a passport and I have an ID card. I could even do crazy things like prove that it's the same name without even revealing the name. Just have to do a bit of circuit work, okay? But then it's going to be really hard to cheat because I can't just buy the passport from someone. I have to also have the ID card and everything. So I think just I don't know if you have good ideas about how to use it. That could be fun. And so there's other teams that are working on similar things. There's a team in Japan that's working with the Japanese ID cards. There's a team doing Anon Aadhaar, which is Aadhaar is a system in India for also with identity, and it's already like implemented and working, so it's quite cool. If you want to experiment with Nova, you can also like at hackathons, for instance, you can also look at this. So it's Pierre, which is working at OXPark and PSC. I know him, he's from France also. He's been doing this work to basically make it possible to use Nova Scotia circuits and to prove them in the browser. So Nova Scotia, for a bit of context, it's like Nalin from OXPark. He's been basically working on this thing in which you can have a little circumcircuit and you can compile it to Nova. And so if you have something that's really repetitive, you can just do a little circumcircuit of one part, and then you can like prove it into Nova. And now you can even do it in the browser. You've got multiple posts detailing how to do it. And so it could be fun to do this kind of things for a hackathon because it's probably doable in a few days if you look a bit at the tool before.
So is there this for this project, does he has a on-chain verifier? Smart contract? Or
I think he does.
backend of Nova is
No.
started
Yeah.
too large.
Yeah. I don't know. I think probably not. I think probably not. We'll have to look at this, but probably not right now. Yeah, you can verify in the browser, it seems, but maybe not in Solidity now.
question. So you mean if I, you know, use my phone with your app to read my passport, so then you can merge, I don't know, then you app can meet SPT for me, right? So I can use this as SPT to prove my maybe some identity or some kind of features to other people.
Yeah.
Yeah. So yeah. So so that prevents some people use my SPT to use my personal SPT to show he satisfied he or she satisfies some features of the requirement, right? Yeah. So my question is, so how about if I stole your passport? Yeah, that could be happen. So I stole your passport and use your app to read your passport, and I own this SPT. So how to solve these issues? So I think it's not a tricky question, but also important.
Yeah, it's true. It's a question about the world. The world is messy and fuzzy. All of those complex problems, like okay, you can steal passport. Well, actually, like right now, there is no easy way to like counter this. There are also similar problems. Like, what if the country revokes the passport? What if you have two passports from different countries? Okay, like two passports from different countries, you can try to like merge different circuits and show that the names are the same or things like that, but it's hard. I mean, you have to have a nullifier, and the nullifier would like show some things to the countries issuing. Well, you don't have any perfect solutions right now for this. I guess the solution is not going to be technical, because there is no way that ZK circuits know magically I'm stealing the passport from someone else. I think the solutions are going to be more social, and like, as I said, aggregation of different proofs. Maybe I'm stealing your passport, but it's not going to be of any use if I don't have also all of the other things like phone number and everything. So yeah.
I think you have to design an SPT contract to maybe have a recovery mechanism.
Yeah, and you can do this kind of things. Like, for instance, if I lose my address, I can just come with my passport on a new like address and mint the SBT, and it destroys the old one. I can also do crazy things like have a smart contract wallet that works with my passport, and so it's one of the shares that are used, like for a multi-sig, for instance. Okay, I don't know if I'm going to lose the key. Well, I just do and it sends the transaction. Okay, it's fun. It can be a recovery mechanism. Yeah.
It also stores some sort of biometrics, right? Sometimes the thumb or the face information, pictures are stored. You see like some sort of fuzzy way of maybe just using your webcam or thumbprint to avoid these kind of.
Well, I think there are some really interesting things to think about. For instance, we have the face, right? We can't get the fingerprint or the iris, and only a few countries really use them. But the face, every country has to use them, and I can actually get it easily. There is no special access control mechanism. So maybe if we could do systems like, okay, you can recover, but you have to show that your face really looks like the thing. Taking a photo, you can do ZK-ML. Problem is that, you know, ZK-ML, it's quite hard today. Also, you have like collision problems, just like WorldCoin is having, even if with the irises, they are not supporting right now more than 1 billion people. The photos from the passport, they are not that good, not 3D scans or things like Apple is using. So some limits, but interesting things to think about.
So when I use a smartphone to read the passport, so does it collect the face data on the passport, the picture?
Yeah, it can collect the picture.
Maybe one solution, maybe